Okay, so here we're trying to figure out some integrals again. The graph f of x is composed of 3 line segments, boom, 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 and a semicircle. Find the equation of the line segment on the interval from 3 to 5. So from here to here, they basically want us to figure out the equation for that. That's easy. And then we need to use that equation to find the x-intercept. We want to find this spot right here. Because when we integrate, we're going to need to break things up because we get a transition from areas that's above the x-axis to areas that are below the x-axis. So we need to find this 0. Well, let's start off by trying to come up with an equation for the line. If you're going to come up with an equation for the line, what's the most important 2 things that you need? You need the slope. So my slope is y minus y, so 3 plus 1 over x minus x, 3 minus 5. So 3 plus 1, that's 4. 3 minus 5, that's negative 2. So I would get negative 2. Point, I don't care which point. Is one better? No, I'll just use the 5 and negative 1 to make sure that we remember how to write it up properly. So I'm going to go with Taylor form. I think that's my favorite nowadays. So that means y equals my y value, negative 1, my slope, times the quantity x minus 5. Okay, so this is the equation for my curve, and I want to use that to figure out this 0 value. So in other words, what value are we looking for if I want to find the 0? What should I do with this thing? Well, think about it. Yeah, if we want to figure out a y value of 0, I should make y 0. So 0 equals negative 1 minus 2 times x minus 5. I'm going to run out of room. So I'm going to go over here. 0 equals negative 1 minus 2x plus 10. That took way too long. That's all right. That's all right, right? 0 equals negative 1. 0 equals negative 2x plus 9. I'm going to bump the 9 over. I'm going to divide by 2. I get x equals 9 halves. So my x-intercept is 9 halves 0. Now we need that. That's going to come into play when we try to do some of these integrals. So I'm going to encourage you to try to do this on your own. First, try to write this as 2 separate integrals because you can't go from negative 7 to 0 because the area has changed from being above and below the x-axis. So break it up, and then try to figure out what they are. All right, let's see how you did breaking them up. So this is the same as the integral from negative 7 to negative 2 of f of x dx plus the integral from negative 2. I always want to just keep starting off where I was, negative 2 to 0 of f of x dx. This one's not too bad. I've got a triangle here, so my area formula for a triangle is 1/2 times the base. So the base is 1, 2, 3, 4, 5 times the height, which is 1, plus, so how much of what's the area, what shape are we talking about here? This is a quarter of a circle. So it's going to be 1/4. Yeah, why did I write 1/2? 1/4 pi, and what's the area formula for a circle? Pi r squared. So it's going to be pi times r. My radius in this case is 2. Oh, thanks, Corpy. So we get 5 halves. 4 cancels, plus pi. I fell for it again. This base is 5. This height is negative 1. Negative. So that's going to make that a negative 5. Give it a try. How are you going to break it up? You need to go from 5 until 2. Right away, that should feel weird to you. Yeah, so actually do the cleanup, but just clean up how you want to rewrite this first. Don't break it up yet. All right, what I think is weird here is it goes in the wrong order. It goes from 5 to 2. I'm allowed to flip these around as long as I realize that that's going to come out to be a negative from 2 to 5 of f of x dx. All right, now I'm going to give you a second. I want you to try to split it up. All right, well, this is where this 0 comes into play. So I want to figure out from here to here, from 2 to 5, but I get a transition at this. So I'm going to go from here to here, and then I'm going to go from here to there, if that makes sense. I don't know how good my drawing is, but so this is negative 2 until we figured out that that transition point was 4.5 or 9/2. You can write either one. F of x dx minus, it's another minus because that negative, you split this into a plus, but then you got to distribute the negative from 4.5 until 5 of f of x dx. I'm not going to, yeah, I can try to show it down here. All right, so my first shape is a triangle, 1/2. My base is 1, 2, 3.5. Can I turn that in? Yeah, let's make that 7/2. Times, no, 7/2. 1, 2.5. My bad. Now I got to go down here. So 1/2. My base is 2.5, which is 5/2. My height is 3. That was easy, right? Because we know that that's the high point there. And that's negative. Minus, okay, now I've got a curve. Oh, this is going to be interesting because this is then negative again. So minus 1/2. My base is 1/2. My height is -1. So what would we get? Why didn't I start over a little farther? Woe was me. So I get -15 over 4 plus 1/4. Which ends up being, what's that, -14 over 4? Which ends up being -7/2. All right, now wait a minute. That's negative. So you're telling me that this area here gets canceled out. There's more negative area? Wait a minute. Figure that out. Pause and figure out, why is this a little bit sneaky? Because this is telling me that the area from here to here, the accumulated area, it means that there's more negative area, but that's clearly not true. So why is this answer actually correct? Where am I getting mixed up? All right, let's see how you did. I'm getting mixed up because remember, this was the integral from 5 to 2. We're going backwards. So yeah, there's clearly more area above the x-axis than below the x-axis. I mean, I'll shade them in. You'll see them. I mean, there's the area under. There's the area above. Clearly, there's more area above. But remember, so this should be a positive integral, but because we're starting here and going backwards, it's going to actually end up being a negative integral. All right, so we've talked a little bit, remember, in a derivative, differentiable, a function was if a function was continuous, my bad, if a function was differentiable, then it was automatically continuous. Differentiability implies continuity. Well, if we're going to do the antiderivative, that sort of relationship would work backwards, and it's true. So as long as your function is continuous, then your function must be integrable. It has integrability. So that's what this is talking about. So we're going to now, I want to take a look at, it says non-continuous functions aren't, it doesn't say, oh yeah, okay, I see what he's saying here. It doesn't mean that just because you're not continuous, it doesn't mean that you're you're not integrable. So let's try to make a sketch of this function. So try to sketch the absolute value of x over x. I'm going to encourage you to pause, see how you do. Now, when I tried to sketch this, I kind of struggled, but once you kind of break it into pieces, it does make some more sense. So let's think about it. I'm only going to go a couple of values. What I would recommend is anytime you see something with an absolute value is to break it up into a piecewise function. So I'm going to take this and I'm going to break this into the piecewise function. I'm going to go this way with it. F of x equals the piecewise function. And let's look at what happens when we plug in negative x's and when we plug in positive x's. That's where things are going to transition here, right? When we switch from being negative to positive. So if I pick all my x's to be negative, well, what's the absolute value of a negative x? It's still x. But what was my x? Negative. So my function is x over negative x for all x's that are less than 0. So if you're negative, when I plug a negative in here, it comes out to be a positive. When I plug a negative in here, it stays negative. Now let's think about it as a positive. What's the absolute value of a positive? And then I make this a positive. This is going to occur for all x's that are greater than 0. Why didn't I write down 0? Well, 0 over 0 is an indeterminate form. That means that we don't have a value there. So really my function ends up being, I'm going to go to a different color. When I clean this up, f of x equals, what's x over negative x? Well, that's negative 1. What's x over x? That's positive 1. So let's I'll give you a chance to pause and try to sketch this thing. All right, so my function is it's literally just negative 1 before, so it's negative 1, not at 0, not included, but it's negative 1 for all the ones before there. And then, oh, it looks like I do need an extra tick mark in here. But the next one's at 1. Goes forward forever. What color was I using? Was it this? Yeah, I need the 3. Because this goes, my integral is going to go from negative 2 to 3. So what are my areas under the curve? My areas under the curve, again, this section is below the x-axis. And then in a different color, this section is above the x-axis. So I have to kind of break my integral up. My integral up. So I can't go from negative 2 all the way to positive 3. So let's break our integral up. We'll start with the integral from, let's do the green area first. So I want to go from negative 2 until 0. Of f of x dx plus the integral from, and now I want to go from 0 until 3 of f of x dx. My math voice is really happy because these are just rectangles. I'm going to slice these so that I can keep track of where I'm checking. I'm going from negative 2 to positive 3. Slice them up so that I can see those shapes. So the shape we're talking about here is a rectangle. The shape I'm talking about here is a rectangle. Pretty straightforward. Let's calculate this rectangle first. What's its length? 2. This is a length of 2 times what's its height? Negative 1. Plus what's its length? 3 times what's its height? 1. So I would end up with negative 2 plus 3, which would end up being 1.